Okay, our next speaker is Chris Brown of Broadcom in Cambridge.
Can you hear me? Yeah? So if you look in the handouts, I think I've got the shortest mention in the handout, which probably means I've been a very naughty boy somewhere along the lines, but not as naughty as I'm about to be now. So a couple of months ago I got an email in my inbox from Mike saying, would you like to come and speak today on what you use Formal for at Cambridge and Broadcom, and why you don't use it more. So I thought, oh yeah, I'll do that. I've been sitting there this morning listening to the other presentations thinking, maybe this wasn't such a good idea. But let's see if I can get through and get out of here alive. So I'm going to talk, to start off with, what we do use Formal for in Cambridge. That will be fairly brief. I'm going to spend more of my time where my expertise is in why we don't use more formal tools. And then see if I can get less questions than I can do. So just to start off with, I find a lot of people don't actually know almost that we exist in Broadcom, so in Cambridge. We are one of Broadcom's largest sites in Europe. Broadcom's got a lot of sites from the various acquisitions over the years. There's about 150 of us quietly sat hidden away on the science park. We're part of Broadcom's mobile group, producing video and imaging solutions for the mobile market. And we're also the home of the Raspberry Pi. A lot of the guys who do the Raspberry Pi actually work for us and allegedly do it on their own time. Don't tell Scott McGregor how much they do on company time. For those of you who were at Snug last week, I'm not going to make the same mistake that one of my colleagues did and spend a lot of time plugging the fact that we're hiring across all our departments at the moment. So I won't do that because this is supposed to be technical. So I'm going to start off with just kind of talking about our formal usage. So our most successful use of Formal to date was in post-silicon bring up. We had a bug in our silicon, very rare, but it does happen. And this bug was very rare in its own right. It would happen once every couple of days or something. And this is real silicon running at megahertz once every couple of days, not simulation once every couple of days. And there was no way it could possibly happen. Well, it did. So what we did was we took the information we had about it, we plugged it into the Formal tool, and the Formal tool showed us where to go look. Now, I'm not the expert on that. David Lucy, who couldn't make it today, he's the expert on that. He gave a great presentation on this at Club Formal. Slides are out there. There's 20 or 30 really good slides on it. So if you want to know the details of it, go there. I blatantly stolen a couple of his slides just to give you a bit of a feeling for it. So it was a problem in our cache. We've got a video processor, it's got a cache. And basically what was happening was writes were going missing. They weren't going to the wrong place, they weren't turning up somewhere they shouldn't, they were completely lost. And to get this to happen, there seemed to be some connection with repeated polling of shared structure, and there's multiple processors. They seemed to be trying to write to the same place. So couldn't reproduce a simulation, hadn't seen the simulation. We do a hell of a lot of FPGA-based verification at Cambridge. Didn't see it there either, but it was happening. So some assertions were created out of the information that we'd got from the Silicon debug. And this is the killer assertion. Nice and simple. Even I could write that one. There were some other assertions as well to kind of get you out of illegal positions and that kind of stuff and check out a few other theories. But this was the killer assertion. It took a couple of hours runtime in the tool, and that's including doing the other assertions. And we got a debug waveform 15 clock cycles long. Brilliant. Job done. The bug was actually in some store detection logic where tag lookups are trying to go to the same place, and the store detection logic was looking for consecutive cycles, and stores further down the pipeline were causing the issue. So I guess our conclusions for this, from this, this formal stuff, it found the problem. We couldn't find it in simulation. It found the problem. The debug was really easy. We got this nice 15 clock cycle trace, and we reckon the amount of time it took us to find this using Formal was probably about the same time as it would have taken to set up a new block level test bench to go after. It's not the time to set up the test bench to go find it, it's the time to set up the test bench. So at this point, we've got the poster child of formal verification. David Lucy was in hot demand. People wanted to fly him over to DAC to tell everybody how wonderful this was. So that, this is serious success stuff. And I still, even now, come across people who tell me, well, I can verify my design with a few directed tests. Or an even more interesting one is verification is only for people who can't design properly. And you still find people who think like that. And I would say, well, the reason is that they've never had to do something really complex. They've never fallen in the big vat of the brown smelly stuff and had to dig their way out. Well, here we did. We did fall in the big vat of brown smelly stuff. We did use formal to dig our way out. So you'd think, well, we'd all be gung-ho, we'd all be doing loads and loads of formal. Well, what we actually do is, of our 50-strong design team, 2 or 3 people use formal. That's it. They're a fairly small select group of guys. They use formal. They mainly use it taking sort of standard bus protocol checks that come with the tool, and they run those. And even them, when they're under pressure, they drop formal and they go back to simulation. So these are guys that have seen the fantastic stuff we did. They're guys that are at the zealot end of the spectrum. So we've got zealots, we've got agnostics, we've got atheists. They're up the zealot end. And when push comes to shove, they drop it. So I was kind of thinking about this. This is, why are we not doing more of this? I've got a verification team of 10 folk. And my previous company, I had larger verification teams across multiple sites. And at no point have any of them ever come to me and said, I want to do formal verification. So I did a little survey. I surveyed the guys that do it. I surveyed the guys that don't do it. And what I found came into sort of 3 classes as what I'm going to call excuses. Those of you who've got children are well aware of this kind of stuff. Now, I didn't do it because, no, she did. I've got 3 children. I'm well aware of what excuses are. Then there's what I've put real technical issues, and I've put a question mark in there because I'm sure there's going to be plenty of EDA people around me later saying, no, that's not real. But I think they're real anyway. And then at the end there's cost, and I'll explain a bit more about what I mean that when we get that far. So excuses. Excuses, I say the kind of things that are based on hearsay and not fact. I'm an engineer, you're all engineers. We like facts, we like proofs, we like data. And these are things that my team came out with very, very quickly. And it's just gossip and hearsay, really. If I had £1 for every EDA tool vendor guy who'd come in and tried to sell me formal tools as a solution to all my problems in the past, I'd be able to buy you all a beer, even an expensive place like this. So that's my snake oil thing. People, in my opinion, have oversold these tools as a panacea. Let's fix everything, and I don't think they are, and they ever will. They're an excellent tool in your toolbox. Another one that came straight out of my team: don't need a PhD in mathematics to do this sort of thing. And I think this comes from those who are longer in the tooth will remember the floating point bug in the Intel processor that caused a big recall, and they hired a load of PhD formal people to go and solve the problem. So that's now set a precedent in people's minds. Formal must need a PhD. Dubious gains. So, if I do formal, what do I not do? Maybe that isn't actually the right question. Maybe we do formal as well. The types of designs, my design is mostly data path, and formal's not very good for data path. My design's too big. I mean, that's definitely hearsay in my group because none of them have ever used it. Maybe their design is too big, but they've got no evidence of that. Some people, this next quote is actually from an ex-colleague of mine, but why would I code my design up again in another language for assertions? I've got far more important things to do than redoing it. But you do find people who are not that into assertions, see it as a waste of time, and then you get whole blocks of damn assertions. Well, I've got whole blocks of, why should I do formal? I can't do formal, I haven't got lots of assertions. Well, you've got some assertions, why don't you go use those? Maybe you get some value out of that. And the other thing I got a lot from my team was always there's a big ramp-up time in doing that. So that's kind of a potted version of the excuses that I got. So some of the more real technical things that I think are real anyway, and some of the stuff I see from the tool vendors, I see them trying to solve these problems, so I think there are definitely some realness to them. When I'm doing my nice UVM test bench in my nice well-known world that I've been doing that kind of stuff for 15 years, I do know what I've achieved. I can use my coverage, I can use my functional coverage, my code coverage, and all that kind of stuff. It's difficult for me to know what I had genuinely really achieved with my formal. How do I review what it's done? In my simulations, I spend a lot of time looking at the failing cases. I ought to actually spend a lot of time looking at the passing cases, but I very rarely do. So, it tells me, the formal tool tells me, yes, I've proved that. What does it actually prove? What have I actually done? Can I really be sure I know what I've done? I think my designs really are too big, but maybe not. One of the problems I have is I've got a team of 10 engineers. They're the norm for verification people in the industry. They're simulation-based verification engineers. They've cut their teeth on SpecMan and Vera and more recently System Verilog, OVM, UVM. They're that kind of people. They know, they understand that world. They live in that world. They're very, very good at it. To me, it's a different knowledge and skill set that you actually need for formal tools. It's not the same skills, and they don't have those. And the next bullet point is actually pointing at me. I don't really know how to extract the value out of the formal tools. I know there's value there. I know I can get a benefit from it. But I also know that I can spend a hell of a lot of time getting nothing from it. So there's a lot of people out there that don't really understand how to extract the value, how to get the 80% for the 20% of effort or whatever it is. I also think that the results of the formula is very, very dependent on how good your assertions are. And there's no way to evaluate this. I guess we heard Doug speak earlier a little bit about what Synopsys is trying to do in that space to help us evaluate how good our assertions are. But I think that there's some way to go in that particular area. One of the things we do a lot of in Broadcom in Cambridge is we drive our designs from the software. So we're developing software drivers on the site. Our software team work heavily with the hardware guys, and we actually work together on the verification. And it's difficult to, we're very software driven. It's difficult to see how that plays in the formal world for me. The next two are actually from the guys who really, really do formal stuff. And they're basically saying, well, we haven't been able to prove some significant things. And when we can't prove it, we've got no idea why we can't prove it. We've got, say, something where we think the state depth is 32, and the tool says, I've gone out to 200 and I still haven't proven it. And I go, what's going on? Is the tool buggy? Is my assertions bad? Do I not understand my design? What's going on? And there's nothing there that they really find that helps them to understand this stuff. So that's my real technical stuff. And if you see me surrounded by EDA guys over lunch, then this was garbage. But to me, I think the bottom line for why we don't do a lot more of this is it isn't high enough priority. I have the manager of my team. I've got to go into my boss and say, I know we've got to tape out 4 designs by the end of this year, and I know that we're up to our eyeballs in work, and I know we haven't done all our simulation work yet, but hey, I want to go off and do all this new stuff. That's a very brave decision for me to go make. I could also go and say, well, those new recs that you've got so I can add to my team, I want to go spend one of those on formal verification. Again, that's a brave decision for me to go. Courageous might be another term, or career limiting is another term. So that's an issue for me that I face as the verification manager. Do I gamble? Do I want to go do that? And the final point I wanted to make, these slides had to go to approval, so this isn't my style, but this is really the metrics of yelling. So people tend, in my experience, to work the way they're measured. For example, my GP surgery, they find out they're going to be measured on how quickly they give people appointments. So what they did was they whacked all appointments, and you can only phone up on the day. So you work to the way you're measured. And what happens in the design teams that I've worked in over the years is the verification guys get measured, they get yelled at if their code coverage is bad, if their functional coverage is bad, if there are parts of their test plan they haven't done. The designers get yelled at if they produce a design that isn't time and clean, that doesn't meet the area goals, that isn't power efficient. I have never seen anybody get yelled at for not using formal. And I think that that comes down to a lack of measurement. I don't see how to measure formal tools. I don't see how to measure the progress. I don't see how to measure what I've done. And I think that if you can put more of that measurement in place, then I think managers like me can go manage to it, and I think you'll see a lot more adoption of the technologies.
Thanks, Chris.
I can see one hand going up already.
Yes, there's a. Would you? Well, let's go to your colleague, Jeff.
One thing that you can measure is how long it takes to debug stuff. And I find a lot of people get shouted at for taking a long time to debug things. And your very first example there was about how quickly you could debug a silicon bug. Have you thought about that aspect of it?
How was that about that aspect of it? So I think that we don't break debug out. Everybody talks about debug being taking a lot of time, and it does take a lot of time. I don't think we break it out enough for that to be obvious. So that's a good point. We could do that.
Was there another question? Was there one spin?
Okay, if you go back one slide, please. So the final question you asked, I have 20 slides answering your question.
Excellent. I'll look forward to it.
We'll see you at 4.
Anticipation. Any more questions? Fantastic. Well, thanks, Chris. That was very interesting.